Hello and welcome to E233. I'm your instructor, Gregory Myers. This video, we're going to take another look at our P3 and particularly how to set up the P3 based on the instructions in this particular example for our physics-based P3. It's quite possible that your P3 will be slightly different, that the formulas and the functions that you use will be different, but fundamentally they're going to be the same. This video assumes a few things. Number one, that you have completed watching some of the fundamentals demos, as well as being able to compile an executable, have some familiarity with the command line, and then also having completed your P2. What we're going to do is we're going to leverage some of the equations that we saw in our P2 tied to the physics demo. It also assumes that you've obtained a copy of the P3 setup, P3 sample, and then optionally this main template. The P3 setup simply has some of our function prototypes in it, and the P3 sample offers us some guidance on our inputs and outputs. In the previous video, we took a second to triage all of the potential switch combinations. And so what we'd like to do is we'd like to convert these switch combinations into our help. And then from there, we're going to construct our if statements that will be used to handle the switches. So I encourage you to keep a copy of this table up. So to begin with, what we want to do is go ahead and go to New Project, and we're going to select a C and C++ application. And we'll call this P3. We can go ahead and check a main file. And at this point, we can finish. And then under your source, you'll see the default license template from NetBeans. Would encourage you to use the main template.c that I provided, and then go ahead and copy over and make the appropriate changes. Now I'm going to leave these changes for you so that we don't make this video too long. And then what we'll do is we'll come back and check at the very end to make sure that you've done it according to the way that I would like to see it. We'll go ahead and preface then our main with a comment block, as well as going back to our P3 setup.c snips file that I provided that gives you the function signatures. Now, before we copy these over, I want to make sure that we understand why we need these. And we can go back over to instructions here, and we'll see that there are three functions that we're going to use for our executable. One is going to be the projectile underscore 1D version 2, which, as I said earlier, is essentially just a modified version of our P2 project. The difference being is that it accepts an input argument of y init. In P2, we had to have the scanf and the printf inside of the function in order to capture the data from the user. In this project, we don't necessarily care where we get the information from. Matter of fact, we can get it from two possible sources, either interactively from the user by providing a scanf and printf in main, or parametrically from the user by simply providing an additional argument on the command line. Likewise, for our projectile 2D version 2, this function accepts two input arguments, the vinit and the theta that's required to do 2D projectile motion. In P2, we had two scanfs and two printfs inside of the function. In this case, we're going to push the responsibility for collecting the information out of the function. And essentially, the function doesn't know where you get the vinit and the theta from. It just simply is provided to it. And likewise for the simple supported beam version 2. Now, all three of these functions return success or failure as an integer. We'll talk a little bit about what the benefits and detriments of that are in a later video, but fundamentally what I want you to get comfortable with is the idea of passing arguments to the functions and then also getting values back from the function. In this case, it's just going to be success or failure. You'll see in the P3 sample.txt that very little has changed from the perspective of what we print out once we run each one of these functions. And this video is not going to focus too much more on that. We'll focus on the output in a later video. Instead, what we want to do is we want to look at how to structure our project. And this is part of that greater concept of top-down design. In other words, what we want to do is we want to look at the structure of a program and how we're going to pass information from one function to another, rather than necessarily how each function works. All right, so back to our P3.c. We want to go to the P3 setup.c, and we want to copy over all of our function prototypes and add them to a list of function prototypes that would be in your main. In this case, we have yet to have any, and so these will become our first function prototypes. And you can go ahead and also copy over each one of these function stubs that I provided for you and simply put them at the bottom of your main. Now, once again, I have left the comment blocks stubbed in. I'm going to assume that you will go back and change, for instance, the function name, the description, and the arguments. Now we're going to need one additional function that I have not provided for us, and that will be our help function. And so we'll do like we've done in an earlier example where we have a void help void. And the idea is that our help will not accept any input arguments, nor will it return any output arguments. Its sole purpose is just simply to print out the instructions for how to use our executable. And so this is going to manage our help. We can simply add this as a function, once again, below the main. And then, as I said earlier, there will be no return here. And so the only thing that we want to do is go back to the template. Once again, add our block comments, which you once again can update later. And what we want to do is start by building out our help. Once again, we're going to take just a second to refresh our memory on the table here of our arguments. We have both a /? and a /h for help. It's up to you how many options there you want to implement, but basically we want to at least have a /h. We have /1d, which will be followed by either /i or /p, followed by additional values. For /2d will also be /i and /p, but with two values for the /p, and /i and /p for beam, with three additional arguments. Keep in mind that we will always have at least one argument, and that will be the name of the executable itself. So we'll always start off our indexing at argv square brackets 0. And you can see here that I provided some examples that you can once again use in the help. So let's go ahead and get started with this. And so we'll start off by having a print statement. Simply specifies that this is the usage of our executable. And then we'll include then maybe perhaps even tabbed over p3.exe. And you can provide either /?, which will run the help. And we said that we also would like to support /h. And what we're going to do is just simply line by line build our help based on that table. So once again, p3.exe, our next option was /1d /i. And this is interactive 1D. And you can make your help a little more informative than this. I'm just sort of trying to get us a nice start on this. There's P3/1D/ P for parametric mode. And in this case, then you would provide the additional piece of information, or the 100. This is the parametric 1D. Continuing on with this, P3, trying to keep consistent here, so capital P3.exe slash 2D slash I. This is going to be our interactive 2D. Followed up with our P3.exe slash 2D slash P. And we said that this requires two pieces of information, the VINIT and our theta, which we've just agreed upon to use as an example, 0.7854, or roughly pi over 4. And this is going to be our parametric 2D. Continuing on, we have a P3.exe slash beam slash I, which will simply run our beam interactive. And then once again, P3.exe with slash beam slash P. And in this particular case, we'll have three pieces of information: the load, the length of the beam, and the location of the load on the beam. And so this will be our beam parametric. And as I said, you can improve the quality of your help significantly. The idea is I just want to get us started. And then, as I said earlier, we would want to go ahead and update the function comments here. And so we'll go ahead and take just a second to do it to give you a good start. I include the entire function prototype, and under the description, then this is just simply going to display the contents of the help. And then for the argument list, we're going to have void, which is no input, and likewise void no output. Okay, so how do we actually employ this now inside of our main? Well, the first thing that we want to do, and I encourage you to do this on all of your executables until you get comfortable with the concept of these arguments and these switches, is we'll simply set up a for loop that loops through all of the available arguments. And to do that, we're going to start off with a variable called index, and we're going to simply build a for loop around the argument count, or argc, that starts off at 0. It continues while the index is less than argc, and we increment the index. In other words, we move forward by 1. And inside of this for loop, all we're going to do is simply print the argument itself. And I'm going to do that in sort of a obscure way, basically little bit, it's going to look a little odd to you the first couple of times. But the idea here is I want to print not only the location in the argv array, but then also the value. And that's going to lead us to these two format identifiers. The first %d is going to simply host the index, and the second one, the %s, is going to host then the argv and whatever the value is at that particular index. And then a nice additional touch here is, before you go into the for loop, is that you simply print out the total count of the arguments, which is also going to be a %d. And in that, we simply drop in the argc. So this displays the count of arguments. And this for loop displays each argument. Once again, I simply encourage you to have this at the top of your main. Later on, when you start getting more familiar with C or programming for command line applications, you can comment this out, or possibly when you give it to your client, you can comment it out. However, it might still be useful in troubleshooting. At this point, we definitely want to have a copy of that table up. And what we're going to do is we're going to leverage both the argument count itself as well as what each one of the arguments are. And so, for instance, we want to recognize that unless there is some strange problem, our argument count should never be 0. And if it is either 0 or 1, we basically want to display the help implicitly. In other words, the user doesn't know how to actually use your executable. And so at this point, what we do is we simply set up our first if statement. And so that if our argc is less than or equal to 1, what we want to do is we want to call our help. But specifically, what we're going to do is we're going to implicitly call our help. In other words, the user didn't ask for help. They just didn't know what they were doing. We can then follow this up with another if statement, and else if. And in this case, what we want to do is we want to explicitly check that argv square brackets 1. And the reason we know that we should have an argv square brackets 1 is the only way that we will make it to this branch of our if else statement is if there is at least 2 arguments. And so what we can do now is we can use our string compare I function. We can compare our argv square brackets 1 against the /h, and if there is in fact a match, then now we can make a call for help. And this I like to refer to as an explicit call for help. In other words, the user actually asked for help. Now, we can extend this a little further by also checking to see if string compare I argv square brackets 1 matches our /?. And at this point, hopefully you can see that there are any number of ways that we can trigger the help. And once again, explicitly call for help. Well, at this point, we've at least got a way for our user to implicitly and explicitly get help. We should probably take a second to go ahead and think what our else is going to look like. And our else just simply means that we have not handled the switch combination above. So we've not handled whatever was passed by the user. And in this case, once again, we want to have an implicit call for help. As you get more familiar with this logic associated with command line arguments, you'll notice there's some improvements that we can make. We're actually checking more than we probably need to. But once again, as we're starting off, a little bit of extra code isn't the end of the world. Now what we want to do is we want to handle the other scenarios, particularly the ones involving the /1d/2d and /beam. And what we can do now is we can do that in conjunction with the argument count. And so for the /1d, /2d, and /beam, I'm going to check to see if the argument count supports those additional arguments. So in other words, if, for instance, that our argument count is 3 and the user has provided /1d and /I, we simply want to make a call to our function, but once again, we have to collect the information interactively. And so we can start off here with a else if and a compound if statement. And so what we'll do here is we'll have our argc, we can either do greater than or equal to 3 or equal to 3. So we'll start off with argc equal to 3. And what we'll do is we'll use our string compare I once again, and we will compare our argv square brackets 2, and we'll see if it matches our /1d. And if it does, if both of those conditions are true, then what we can do now is we can look at the additional arguments. Now, the problem with this is, and actually, let me take a step back. This is going to be argv square brackets 1. The problem with this is the difference between the /I and the /P means that there can be additional arguments. And so once again, we come back here to our slide and you'll see that we have two choices. We either check explicitly that our arg count C is equal to 3, or we check to see if it is equal to or greater than 3. Once again, two different ways of looking at the problem. And what I'd like to do is, rather than have a flat structure, I would like to use a nested structure to handle the 1D, 2D, and beam. So what I'm going to do now is I'm simply going to check to see that our arguments are greater than or equal to 3. And then I'm going to go through and I'm going to look specifically at what it would take to do the parametric mode. To understand what I'm doing here, I'm going to switch this now to greater than or equal to. And now inside, we're going to have another if statement. And this string compare I is going to look at our argv square brackets 2. And it's going to check to see if the user has called interactive mode. And if the user has called interactive mode, then in this case, what we're going to do is we're simply going to put a printf statement for right now. And we're going to say calling /1d interactively. We'll get back to actually calling the function in our next video. Under the else if, what we're going to do is we're going to once again check two conditions. We're going to check to see that our argument count was equal to 4 and that the string compare I for our argv square brackets 3 matched the /P, or sorry, once again, accidentally going too higher, argv square brackets 2. And if the user has provided the /1d switch and /P, then what we want to do now is we want to call our /1d, but this time what we want to do is we want to call it parametrically, meaning that we're going to get the remaining piece of information from the command line. Lastly, under the else, we simply want to make an implicit call for help. Now, before we leave this branch of our if statement, we want to go ahead and insert one more print statement at the root here of this nested if statement. And the only way that we can get here is by simply trying to call one of our 1D options. We don't necessarily know which one based on our argv square brackets 1. However, though, we want to at least go ahead and set up our if statement and the print statement so we have some confidence that the structure is correct. So let's go ahead and follow this up now with our 2D version. So very similar. We'll have an else if, and once again, same argument as before. We know that we should have at least 3 arguments. So what we'll do here is we'll look to see if our arg count is greater than or equal to 3. And string compare I, comparing our argv square brackets 1 against our slash 2D, means that no matter what, the user is trying to call one of our slash 2D options. We don't know which one yet. That's going to be handled by this nested if statement that starts to look at our argv square brackets 2. So if our string compare I, argv square brackets 2, and if that matches slash I, then that simply means that we want to call our 2D option, slash 2D option, interactively. Likewise, going back to the table that I provided for you, we should now have a else if, and this is going to result in a compound condition. First, checking to see that our argc was going to be equal to 5. Now, where did I get the 5 from? Well, if we want to call our executable parametrically in the 1D option, we needed 4 arguments. That was our y-init was the additional argument. If we want to do it in our slash 2D option, we needed 2 additional pieces of information. That was going to be our v-init and our theta. And so in this case, we need a total of 5 arguments, and our string compare I, argv square brackets 2, must match slash p. If you're a little bit uncomfortable with this particular if statement, I encourage you to take another look at the table that I have provided for you. And then we simply want to do calling slash 2D parametrically. And then just like in the first branch, our else will simply make yet another implicit call for help. At this point, you probably figured out the pattern for the beam. And so what we want to do is, once again, we'll start with an else if, a compound if statement that checks not only our argument count is greater than or equal to 3, and string compare I of our argv square brackets 1 matches slash beam. And if that's equal to 0, then we know that the user is trying to call our slash beam options. Once again, we don't know which one because we have to look at additional switches to determine. But this is where the nested if statement once again comes into play. And we use our string compare I to look at argv square brackets 2. And if they want the slash I switch, or if they pass the slash I switch, then we know that the user wants to call the slash beam interactively. And just like before, when we want to call the slash beam parametrically, we need to do a total argument count. Now, keep in mind, we have 3 pieces of information that we need to pass: the total weight, the length of the beam, and the location on the beam. So that is going to result in argument count equal to 6. And specifically, what we want to have is that our string compare I of argv square brackets 2 matches that slash beam. And if those 2 conditions are met, we have a printf calling the slash beam parametrically. You do want to make sure to include the new lines on each one of your print statements. And then, of course, under the else, we simply want to make another implicit call for help. All right, so we seem to have a typo here. Let's take just a second to see if we can't discover where it is. I'm going to go ahead and build this, even though I know that it's going to fail. And we just need to figure out where, aha, there we go. No, actually a little bit sure here. There's that match, there's that match. All right, I'll tell you what I'm going to do is temporarily remove this, and I'm going to see if we can eliminate the error. Way up here, there we go. All right, so once again, nice example here of a mistake in code much earlier that caused the problem to appear later. And now, still have a problem here though. Let's see if we can, we're just going to retype this here. Printf calling slash beam parametrically, followed by a new line and then a semicolon. And I'm going to go ahead and build it. All right, so we've got a typo here somewhere that I'm not immediately seeing here. Those of you who are following along were probably trying to tell me through the screen what was going on here. I had simply left off my if on line 60. So remember that it's an if, else, if, else. All right, at this point, we should be able to go ahead and build it. Now, you're probably wondering why I chose to do it this way. There is more than one way that you can go about doing it. You could technically have a completely flat if structure. The disadvantage with that is that it would check essentially every one of our options. This nested if structure may check certain conditions more than once, but technically it's fewer conditions to check. And so once again, it's just a trade-off, a balance. I wanted you to get some exposure to both. Once again, little typo there in our printf, and we should be ready to go. At this point, what you want to do is go ahead and open your command line up. Go ahead and cd to your project location, wherever that might end up being. In this case, it's going to be courses EE233 projects, and like to look at our P3 project, my dist folder, debug NGW. There's our p3.exe, and if we run it with no switches, we should in fact get the help. More importantly, we'll have a count of 1. That is the argv square bracket 0, or the name of the executable. We do get the help. Let's check to see how the other ones work. So /? pulls up the help. Remember, that's an explicit call to help. /h, once again, another explicit call for help. And then let's follow this up just to see what happens if we put in nonsense. So far, so good. Let's see about some of the other switches. Well, we want to see what happens when we put in just /1d. Well, there is no option for just /1d. We either have to provide /i or /p, and you'll notice that we once again got the help, and that is the correct behavior. So if we follow this up with /1d /i, we get the prompts on the command line letting us know that we are calling our /1d options, calling /1d interactively. And if you'll go back over to your code, you'll see that is exactly what we had wanted to have happen. So in other words, if our argument count was 3 and our argv square brackets 1 was in fact 1d, which is the case, we check to see then what our argv square brackets 2 was, and if it was interactive, then we would call 1d interactively. So far, so good. What if we did /1d /p, but forgot the additional argument? We would once again expect to get the help because we need to provide one more piece of information. And now with that additional piece of information, we have a total of 4 arguments, with that 4th argument being the initial height. /p is going to be argv square brackets 2, and so on. Continuing on now with the /2d, without providing an additional piece of information, we should get the help. If we do /2d /i, we do in fact get the calling /2d options as well as calling /2d interactively. And then if we do the /parametric, we of course are going to get the help again because we need to provide the 2 additional pieces of information. And once again, now see calling 2D options as well as calling /2D parametrically. Same is true now for the beam. No additional information results in the help. /beam /i gets us the beam options and /beam interactively. /beam /p gets the help, and /beam /p with the correct number of arguments will of course get us the calling /beam options. But we seem to have a problem here with this one. Let's go back and take a quick look. Yes, another mistake here. We've checked our argv square brackets 1 matches /beam, but we forgot or mistyped the argv square brackets 2 as /p. We'll go ahead and build this. And we should now be able to check that last option. And we do, in fact, get /beam options and calling /beam parametrically. Turns out on line 60, I had accidentally checked my argv square brackets 2 as being /beam or against /beam when that should be only for argv square brackets 1. So hopefully you found this video and particularly a couple of my mistakes useful. Sometimes I make this look a little too easy and I don't mean to do that. As always, if you've got any questions or comments, don't hesitate to reach out to me, and thank you for watching.